আমাদের স্টপ অ্যান্ড ওয়েটটা হয়ে গেছে, স্টপ অ্যান্ড ওয়েট প্রোটোকল। The stop and wait for noiseless, stop and wait automatic repeat request. এটা হচ্ছে স্টপ অ্যান্ড ওয়েট অটোমেটিক রিপিট রিকোয়েস্ট। এটা তো আমরা আগের দিন করলাম, সেন্ডার সাইড অ্যান্ড রিসিভার সাইড প্রোটোকল। এটা বুঝতে পেরেছো তো? কারোর কোনো অসুবিধা থাকলে বলো। ঠিক আছে তো? হ্যালো, এই শোনা যাচ্ছে? স্ক্রিন দেখা যাচ্ছে, শোনা যাচ্ছে, দুটোই হচ্ছে তো?
হ্যাঁ ম্যাম।
ঠিক আছে। তো এটা তো আমরা আগের দিন ডিসকাস করলাম। তো এখানে স্টপ অ্যান্ড ওয়েট ARQ, দ্যাট মিনস স্টপ অ্যান্ড ওয়েট অটোমেটিক রিপিট রিকোয়েস্ট। তো যখনই কোনো ডেটা করাপশন হবে, এখানে সিকোয়েন্স নাম্বারটা রেখে দেওয়া থাকে। যখন সেন্ডার সেন্ড করছে কোনো ফ্রেম, তো সেই ফ্রেমের করসপন্ডিং সিকোয়েন্স নাম্বারটা সেন্ডার স্টোর করে রাখছে, ঠিক আছে? তারপরে হচ্ছে সেই করসপন্ডিং সেই ফ্রেমটা যদি তার অ্যাকনোলেজমেন্ট না পায়, সেন্ডার যদি না রিসিভ করে রিসিভারের থেকে, তখন কি করবে, ওই যে সিকোয়েন্স নাম্বার স্টোর করেছিল সেই জন্য ওই 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 ফ্রেমটার একটা কপি, তার মানে একটা কপি রেখে দিচ্ছে, সেই কপি ফ্রেমটা আবার হচ্ছে পাঠিয়ে দিচ্ছে। যদি টাইমার আউট হয়ে যাচ্ছে এবং অ্যাকনোলেজমেন্ট রিসিভ না করছে। তো আর একটা কেস হয়, ধরো ডেটাটা রিসিভ হয়েছে কিন্তু অ্যাকনোলেজমেন্টটা লস্ট হয়েছে, এই কেসটা অ্যাকনোলেজমেন্টটা লস্ট হয়েছে। সো অ্যাকনোলেজমেন্ট যদি লস্ট হয়, তখন কি করবে, তখন এখানে যে রিসিভার তো ধরো 0th ফ্রেমটা অ্যাকসেপ্ট হয়ে গেলে রিসিভার অ্যাকসেপ্ট করতে চাইবে 1 নম্বর ফ্রেমটা। কিন্তু যদি অ্যাকনোলেজমেন্ট না পায় সেন্ডার, দেন সেন্ডার কি করবে, আগের ডেটাটাই আবার সেন্ড করবে। তো আগের ডেটাটা যদি আবার সেন্ড করে, তখন সেই ক্ষেত্রে কি হবে, রিসিভার দেখবে যে ওটার এক্সপেক্টেড যে ফ্রেম সেটা নয়, তখন কি করবে, ওটাকে ডিলিট করে, মানে ওটা আগের মানে এটাকে ডিসকার্ড করে দেবে, এই ফ্রেমটাকে ডিসকার্ড করবে এবং অ্যাকনোলেজমেন্টটা আবার পাঠাবে। তো দেন অ্যাকনোলেজমেন্ট তখন রিসিভ হয়ে যাবে, ঠিক আছে? তো এইভাবে জিনিসটা হলো। এগুলো কিছু এক্সাম্পলস আছে, তো গো ব্যাক ইন প্রোটোকলে আমরা আসবো। আচ্ছা, so this is the flow diagram of stop and wait ARQ, okay, automatic repeat request. So automatic repeat request is, that means the request is automatically done from the receiver, that means from the receiver end, and automatically that value has to be, the frame has to be sent to the receiver, okay? And if there is any data corruption, then data must be resent again, because there is a mechanism to store the sequence number of the sent data, and the copy of that frame should be stored in some buffer, and if there is any loss of the frame, then data should be resent, okay? So this is the flow diagram. So now take an example. Assume that in a stop and wait ARQ system, the bandwidth of the line is 1 Mbps, okay, that is the channel capacity, and 1 bit takes 20 milliseconds to make a round trip. That means the whole thing, that means 1 bit received by the receiver, and then it is acknowledged is received by the sender. So whole things should be done in 20 milliseconds. What is the bandwidth delay product? That is the first question. And if the system data frames are 1000 bits in length, what is the utilization percentage of the link? Okay, so here bandwidth delay product, so we have 1 bit 1 Mbps, the bandwidth is 1 Mbps, so make it bit per second, so it should be 1 into 10 to the power 6 into 20 milliseconds, so make it a second. So how much time it will take? It will take 20, how many bits? That is bandwidth delay product is what? That is 2000 bits. Okay, 2000 bits they can send. If the system data frames are 1000 bits in length, what is the utilization percentage? Utilization percentage টা দিব না এখানে। তো এই যে এইটা করতে হবে। So if what is the utilization percentage of the link, then the bandwidth delay product is 20,000 bits. The system can send up to 15 frames or 15,000 bits during a round trip. That is given that this is given that can send up to 15 frames before stopping and worrying about the acknowledgement. So 15 frames they can send. So that means 15,000 bits. Okay, one frame means 1,000 bits. So 15 frames, 15,000 bits during a round trip. This means utilization is 15,000 divided by 20,000. Okay, so 20,000 bits they are passing. The channel bandwidth, that bandwidth delay product is 20,000 bits, and 15 frames they want to send. So utilizations should be 15,000 divided by 20,000, so up to 75%. Okay, so if there are damaged frames, the utilization percentage is much less because frames have to be resent. Again, you have to resend the frame. Okay, so this is a small example. Now we have to go for another protocol, that is go back N protocol. And here the sequence numbers are modulo 2 to the power m, where m is the size of the sequence number field in bits. That is the sequence number field. So m is the size of the sequence number field. So go back N protocol. What does it mean? So at first see this send window for go back N protocol. So here we have some frames, and if the value of m, if m is suppose if it is 7, okay, if it is 7, then 0 to that means 2 to the power 7 minus 1. Numbers are modulo 2 to the power m, where m is the size of the sequence number. M is the size of the sequence number. তো এখানে দেখো ফার্স্টে frames already acknowledged, this 13, 14 and 15. So we have 0 to 15, these numbers, these frames we need to pass. That means 16 frames we have. That means bit size is what? That is 4. M is to be 4. Okay. Sequence number size is 4. So that is this is not 7. This is 4. Okay. So 2 to the power 4 minus 1. So that means you have a 15 frames. So here the 13, 14 and 15, these frames are already acknowledged, and 0, 1, 2, 3, 4, 5, 6. These frames are sent but not acknowledged. These frames are sent, and frames that can be sent, that is frames that can be sent, that is but not received from upper layer, this can be sent. So here is the SF, this is the first frame, and SN is the next frame to send. Okay, so SF, two things we should mention here, that is SF and SN. SF is the first frame, that is first outstanding frame what we need to send, and SN is the send window, next frame to send. This is next frame to send. Okay, so SF and SN, we will use this sequence number. So these are the things, and if m equal to 3, that means what? 2 to the power 8 minus 1, that is 7. Window size is 7. So here we can send the 7 bits, and we have 15 frames. 15 frames we have, but we can, and after 15 frames we can again repeat 0, 1, 2, 3, 4, 5, 6 up to 15. Okay, but window is here, I think it is taking m equal to, okay, It is not given. So m equal to 3, I think. Then the size is 0 to 6. That means 7 frames. Same window size is this. Okay, that is the send window. This is the send window, and this is the send window next frame to send. So 2 categories are there, you have to know that. And first category is the first outsending frame which is already sent, but the acknowledgement is not received, and another is the next frame need to send, okay, and it is not received by the upper layer. So this window concept is very important here. So to send window is an abstract concept. This is an abstract concept defining an imaginary box of size to the power m minus 1 with 3 variables SF, Sn and S size. Okay, we have SF, we have Sn and S size. The send window can slide one or more slots when a valid acknowledgement arrives. Okay, send window can slide one or more slot. When the acknowledgement arrives, then it can slide the next slot. And receiver window, this is for receiver window. Receiver window is a single bit, there is a single frame it can receive at a time, and it can receive the single frame at a time, and again after receiving the frame it can slide to the next frame. Okay, so this is the received window for go back in ARQ. So this is the sender window, that is we can send 0, 1, 2, 3, 4, 5, 6, okay, but receiver can only can hold, expect only single frame at the receiver end, that is Rn. Okay, so the receive window is an abstract concept defining an imaginary box of size 1 with one single variable Rn. The window slides when a correct frame has arrived. Sliding occurs one slot at a time. So this is a design of go back in ARQ. Okay, here we have first out, see, this is the first outstanding, the red mark, this is the first outstanding frames, and this is the next to send. So here the sender is getting the data from network layer, that is getting the data from network layer, and from network detailing layer receive the data and it sends to the physical layer, and after that through the transmission medium it can send the data to the receiver, and receiver will receive the data. Receiver will receive the frame and it will deliver the data to the next the upper layer. So here is the acknowledgement number. They can pass the acknowledgement number. So acknowledgement frame they are passing. So from the receiver, the sender can get, even here also they can get the acknowledgement. So this is the there is a problem of in case of go back in ARQ. Okay, in go back in ARQ we have a window size. There is a window size problem. See, the window size is less than 2 to the power m. Okay, window size is less than 2 to the power m, and here is less than if the window size is equal to 2 to the power m, then what will be the problem? Here the size of the window must be less than 2 to the power m. So this is the go back in sender algorithm. So here at first you have to provide the sender window, that is SW is equal to 2 to the power m minus 1. This is SW. This is equal to 2 to the power m minus 1. SF equal to 0. Sn equal to 0 initially. And window size is 2 to the power m minus 1. Okay. Now the same thing, the repeat forever, you have to take a while loop and wait for the event. If event request to send is true, then a packet to send, the packet is sent. So if Sn minus Sf greater than equal to Sw, that means the Sn minus Sf, you have to just calculate it. If it is greater than equal to Sw, that means the window is full. If the window is full, then sleep. If window is full, you can't store the data, so you have to sleep, otherwise get data. Okay, get the data and make frame Sn. This is the first frame Sn and store frame Sn. The sequence number you need to store and then send the frame. So these operations need to occur. So send frame Sn and then Sn equal to Sn plus 1. After sending the value, the sequence number, you can increase the number. So if it is 0, it should be 1. So if timer not running, then start timer. After sending the value, the frame, you need to start timer. Then if event arrival notifications, that is acknowledgement is received, okay, if acknowledgement is received, then receive SEK. So the if corrupted SEK, if SEK is corrupted, then what to do, that is sleep. And if acknowledgement number is greater than SF and the acknowledgement number is less than equal to Sn, it can be less than or equal to Sn, or it can be greater than SF. That is greater than SF, that means first frame. Okay, acknowledgement should be what? That is the next frame next frame to be sent to the receiver. That is the acknowledgement number. Okay, if you are sending frame 0, so you are getting the acknowledgement SEK 1. Okay, so that's why if acknowledgement number is greater than SF and it should be less than equal to Sn, that means it is a valid acknowledgement. And while SF less than equal to SEK number, when it is received, while SF equal to less than, the acknowledgement what you are receiving, that is less than or it can be equal to acknowledgement number, then parse frame, that means the frame is actually properly received by the receiver, and you can just discard the frame from your buffer, and SF equal to SF plus 1. Now your frame number, first frame number should be increase 1, SF equal to SF plus 1. Then stop timer. Okay, then you have to stop timer. Now the timer expires. If the timers expire, if event timeout, then start timer, then temporary, if there is any corruptions happen, okay, then you have to do what? You have to resend the frame again. Okay, so in that case, start timer and temp equal to SF, and while temp less than Sn, that is the temp equal to SF, this is the first frame you want to send. So if temp, you have to check again that whether this is less than Sn or not. If it is less than Sn, okay, less than Sn means next frame you want to send. So if it is less than, the value is less than, then send frame SF and increase the value of SF by 1. Okay, so one thing, there are two things can arise. First thing is acknowledgement arrives. If acknowledgement is received by the sender, then these operations will be performed. And if the timer out and acknowledgement is not received, if sender is not received the acknowledgement, then it can do these operations. Then timer time is out, and then it will it will store the first frame into a temp into a variable, and you have to check that whether that value is less than Sn. Okay, and the sender can resend the frame, send the frame and increase the value of SF equal to SF plus 1. So this is the sender side operation for go back in sender algorithm, and this is for go back in receiver algorithm. So here Rn equal to 0 at first, then while true, then wait for the event. If event arrival notifications, that is data frame arrives, if event arrival notification is true, Then receive frame. If it is corrupted frame, if the frame is corrupted, then it can be sleep. The frame is sleep. Okay, so if the frame is corrupted, then it should not be accepted. And if sequence number is equal to Rn, if it is a expected frame, if sequence number is equal to Rn, if it is a expected frame, then what to do? That is delivered data, data needs to deliver, delivered data, and Rn equal to Rn plus 1. Okay, this is the delivered data, and Rn, that is the receiver, the receiving number, this Rn should be increased. That means next frame it will be received. Then send acknowledgement Rn. Okay, so and this is the procedure for go back in ARQ receiver algorithm. So at the receiver end, it will check whether the frame is corrupted. If the frame is corrupted, then there is sleep, and if it is not corrupted, then it will check whether the sequence number is equal to Rn. What that means, the frame what the receiver is getting from the sender, that is equal, that is the expected frame or not, it need to be checked, and then it will deliver the data, and then data should be delivered, and then it will increase the data Rn equal to Rn, it will increase the frame number, that is Rn equal to Rn plus 1, and then send acknowledgement. Okay, it can send the acknowledgement to the sender.